Fine, so this is question 2 of the textbook on page 71, topic 2.2. We've got here an object of weight 50 newtons is suspended vertically by two strings as shown. Now, firstly, let's continue reading the question. The strings are the same length and the angle between them is 60 degrees. Draw a free body diagram of the forces acting on the object and calculate the tension in the strings. So to draw the free body diagram, basically we'll use this point over here as a center because that's where the strings are attached. Now we have a force downwards due to its weight, and that's 50 newtons. And then there are two other forces acting on by means of the strings, so it would be that force there and that force there. Now those should be obviously of the same length to signify that the forces are equal due to the strings being of the same length and the symmetry of the whole situation. Now the important thing here really is that the resultant of these two forces, if I call this T1 and T2, tension 1 and tension 2, the resultant force, the resultant vertical force. So this is the free body diagram here, this is what you draw, but if I made the resultant vertical force of this, it should cancel out this 50 newtons downwards because the object is stationary and therefore all the forces are in equilibrium. So the resultant net force, you're going to have two forces here. You're going to have a horizontal force in that direction, a horizontal force, and those two will also cancel each other out. The net force on this whole system, the net force is equal to 0 newtons because the object is stationary. So we want to calculate the tension in the strings. Now, because this is 50 newtons, the vertical force by each string would be 25 newtons, like that. And so by the symmetry, this must be 30 degrees, and so I can use trigonometry just to work out this length over here. This would be the tension. So I'm going to get adjacent, which is 25, over the hypotenuse, which is T2, and that would obviously equal the cos of 30 degrees. So T2 is equal to 25 divided by the cos of 30 degrees, and we would, when you put that into our calculator, let's get my calculator, we're going to have 25 divided by the cos of 30, and I get 28. The tension is equal to 28.86 newtons. Now let's just check the number of significant figures I've got. It's down to two significant figures, so that would be 29 newtons would be your tension. Alright, good. Actually, we could even make this probably 30 newtons because perhaps this is 60 and this is 50. Maybe it's to the nearest significant figure. So either one of these, 29 or 30, would be fine. Okay, so that was question 2. Now, going down the page, we're going to be looking at question 4, where we have the diagram shows two blocks connected by a string that passes over a pulley. Block A has a mass of 2 kilograms and block B has a mass of 4 kilograms and rests on a smooth table. Now that smooth is telling you basically that it's frictionless. Determine the acceleration of the two blocks. So if I have a look at, if I think of A, I've got a force downwards there. That's going to be about 20 newtons. The weight, 10 times 2, if we take 10, is your acceleration due to gravity. Now, the 4 kilograms here of your 14 newtons, because it's resting on a table, there is going to be a reaction force there of 14 newtons. So the only unbalanced force on A is actually going to come from the tension in the string, which comes from this 20 newtons. So this 20 newtons, because we've got this string attached, is the accelerating force. This is actually the resultant force, the force resultant on the whole body, and that's equal to 20 newtons. And if we think of F is equal to ma, that's going to equal the mass of the whole system, which is 4 plus 2 times the acceleration of the whole system. So your acceleration is actually going to be 20 over 6, and we get for that 3.33 meters per second to the negative 2 is your acceleration. Because we've got it to one decimal place or two significant figures, we would write that as 3.3 meters per second to the minus 2 would be your acceleration. Okay, so that's question 4. Thank you very much.